Welcome everybody on this, what is in the UK, very rainy Thursday afternoon. I'm just going to wait a minute so that everybody can join us. But as you're waiting or waiting for people to join, just say hi. It's always lovely to know that we've got people with us, listening to us and watching us. And then in a minute, I'll explain what the session is today and also introduce our guests. So we'll wait a minute, and then if anybody is joining, please do feel brave and say hello to us. It's always lovely to have a hi. But just for those who are joining and logging in, hello. We're just going to wait a minute for people to join, but please do say hello if you're here, and start thinking about any questions as well. So on our topic today, and in a minute I'll introduce our guest. So you can see a comment that we've got in the chat from us, the National Extension College, just noting around questions. So I'll start the little preamble now. Welcome everybody to another in the series of the National Extension College webinars, and these are information webinars that we deliver with our partners, and this is to widen opportunity and exposure to different subjects and different careers. Hello, thank you for saying hello. Very brave, it's good to start. Hopefully that will snowball with other people. So as we've said in the comments, please do, as you're working through the session with our guest, who I'll introduce in a minute, please do write any questions, any comments. We'll either pick them up immediately if it works. Otherwise, we'll have a Q&A session at the end. So do have a think. I'm delighted to welcome Dr. Sheila Kanani, who's from the Education, Outreach and Diversity Officer. I said it much better than that in our practice. From the Royal Astronomical Society. It's a pleasure to welcome you. I don't think you delivered with us before, have you, Sheila?
No, I haven't, no.
Good. It's wonderful, and I'm sure you've got some really interesting things to talk our guests through. Hello to those who are saying hi. We've organised this webinar on the premise that there was the World Space Week last week. So that was from the 4th to the 10th of October, and we did lots of social media. I think there was lots happening, wasn't there, Sheila, on social media as well. So this is a sort of the bookend, the end of that particular event, and this will be live on YouTube and available to watch back for anyone who doesn't manage to see the beginning of your presentation. So I'm going to hand over now to you, Dr. Sheila Kanani, and we'll pick up at the end with any questions.
Thank you. It is a pleasure to be here. Thanks for taking your time out to listen to me talk about careers in the space world or universe. It's great to be speaking as part of World Space Week, and I really enjoyed the theme and the sort of graphics for World Space Week 2023 this year, particularly that pink spacesuit. I think if I ever go into space, I would absolutely love a spacesuit like that. So I am here today on behalf of the Royal Astronomical Society, and I'll talk a bit more about that later. Our motto is whatever shines should be observed. And as in my role as diversity officer, I definitely believe that space and astronomy is for everyone, and everything that we can observe and everything that we can work together to observe is fantastic. The sort of title of this talk, I know, is to do with space careers, but I wanted to kind of bring that a little bit back to me and how the solar system and how space has affected my life and where I've ended up. So the kind of tongue-in-cheek title is How the Solar System Changed My Life. So I have been working in the space industry for coming up for 20 years in one form or another. I've been really lucky. I've been a research scientist, a teacher, an educator, and had my current role for almost 10 years. And this sort of love and inspiration of space and sciences has taken me to lots of different countries. I've met lots of incredible people, and I've got things from studying STEM subjects and being in the space world that I couldn't have imagined before. Now, one of the problems with that is that I've got something we now call a portfolio career. When people ask me what I do, I feel a bit like a kind of jack of all trades, master of none, because I do lots of different things. Every single day is different. So I have a PhD. So I'm called Dr. Kanani. My first name's Sheila. You're welcome to call me Sheila. I am a teacher, so I get called Miss quite a lot. And in school, sometimes I get called Dad as well, which isn't right. I'm married and I have a married name that's Mrs. Pearson, but I use Dr. Kanani for all the work that I do. And then I have sort of, handles and letters and numbers and things before and after my name, depending on what things that I've done over the years. Like I said, I'm a physicist, a teacher, and an astronomer. I'm also a mum to 2 young boys. And more recently, I've been an author as well. I'm not an astrologer, though. And if you're not sure of the difference between astronomy and astrology, do feel free to ask afterwards. There is no such thing as a stupid question. But what I'm going to do today is talk to you as the Education Outreach and Diversity Officer at the Royal Astronomical Society. The Royal Astronomical Society is based in central London, near Piccadilly, in a building called Burlington House. We've been there since 1874, but the RAS has been around since 1820, so it's just over 200 years old. It's a learned society, which means it represents astronomers and geophysicists across the globe. We publish academic journals. We have an extensive astronomical library. We organise meetings and events and conferences, and we do a fair share of education, outreach, and diversity as well. The bottom left picture is our first president, astronomer William Herschel. And William Herschel was the astronomer who discovered the planet Uranus, amongst other things. He also had a very famous sister, Caroline. And our last but one president is the man next to him, Mike Crews, Professor Mike Crews. And he will forgive me in saying that the reason I show these two pictures together is to show that over the last 200 years, the face of astronomy hasn't really changed. And part of my role as diversity officer is to try and get more diverse people believing that the space industry and the space community is for them. Our last president was Professor Emma Bunce, who is obviously very different from William Herschel. But there were some statistics, and there were things like there have been, over the last 200 years, there have been more presidents called John than there have been female women presidents. So that needs to change. But it is a fantastic place to work, and it does lots of different things. But the kind of main MO is to encourage and promote the study of astronomy, solar system science, geophysics, and closely related branches of science. So I do 3 different things there. I cover education. So I teach GCSE astronomy, and I work with other educational organisations such as the Institute of Physics and the National Schools Observatory. We go into schools, we run assemblies and workshops, we have school visits to the RAS, we do lots of different things with uniform groups like Girl Guides and Scouts. But then we also cover public outreach as well. So we will go out into the public and talk. We will have the public visit us. We do media, we do science festivals, and we organise our National Astronomy Meeting, which is our annual conference. And then the diversity role was the newest thing to me when I started 10 years ago. But we run surveys and collect data about different issues. We have ambassadors for diversity. We write lots of policies and do lots of training. One of the most recent things we've been looking at is the workplace environment for astronomers and geophysicists in universities and in academia, and looking at whether there's a bullying and harassment problem. And if there is, if we can find the data to prove this, then what are we going to do about it? And how can we make the science community and the space community a better place for everyone? So there's lots of different careers in the space industry. It really does depend what your ideal job might be, what you can see yourself doing in the future, and what sorts of things that you would like to do. When I was younger, I didn't really know that my job now existed, or maybe it didn't exist, and it's changed over the years. So it's not like you have to decide now in order to know what you're doing in 20 years' time. You can very much have a portfolio career. But in terms of what jobs you can get if you do a physics degree, well, the world really is your oyster. You can kind of do anything. Physicists and astronomers do lots and lots of different things, and there are lots of different options available to people that have had a background in physics and astronomy as well. So our website is ras.ac.uk. There are some education and outreach pages on there, and one of the best documents that we've created is a careers booklet called Sky High and Down to Earth. And it goes through different pathways to having to finding a degree and having a career in the space industry. For example, looking at astronomy in more detail, but also looking at geophysics. And the reasons that we represent astronomers and geophysicists are down to a historic feud about 100 years ago that I won't go into now. But it's not just about the academic side of things, it's about the transferable skills that you might need or gain with an astronomy or geophysics related career. So it could include scientific and technical skills, it could be logical approaches to work, it could be strong computational skills, it could be teamwork and team building or leadership. There's all sorts of different things involved. And if you do work in the space industry, what you might do varies as well. So you could do hands-on research in the field or in a laboratory. You could be building parts of satellites. You could be testing those satellites. You could be using equipment like telescopes or seismographs or drills to find out about new places. You could be developing software or hardware. You could be analyzing data, testing theories, searching for new energy resources, launching things into space, studying volcanoes. It's really, really wide. And that's one of the things I really love about working in the space industry. So you might work in the field, which is a kind of collective term for the industry, but you might actually work in a field as well. I've got a colleague who is a meteorite scientist, and during lockdown was part of the group that found the meteorite that landed in somewhere near Stonehenge it was. And they literally went and walked through fields and fields and fields looking for something that could have been the lumps of rock from space. But then you could work in laboratories, observatories, museums, planetaria, universities, or even under the sea. So there's lots of like Mars analog missions where people can go and live under in kind of containers at the bottom of some of the oceans and pretend to be astronauts and live in those sorts of conditions for like a week or two. There is the academic route, so that would include GCSEs or equivalent in relevant subjects, and then A-levels or equivalent in relevant subjects. So I did physics, maths, chemistry, Spanish. I really loved the physics and the Spanish. I thought the maths was difficult, but I needed it to do the physics. And ever since leaving school, I realised that maths is kind of taught in the wrong way at school, and that's why everyone thinks it's difficult, but actually it's brilliant. You know, it is the language of physics. Chemistry I still don't really get on with, but that's another story. And then you could go on to do an undergraduate degree, and then a master's, and then a PhD, and that's the route that I took, but it's not necessarily the only route or the correct one. So I did my undergraduate degree at Manchester University. I did physics with astrophysics. It was an MPhys, which means it was a 4-year integrated master's course. And then I had, before uni and after uni, I had some time out, gap years, and went traveling and working abroad. And then I did my PhD at the Mullard Space Science Laboratory, which is based in Surrey, but is part of UCL in London. But there are other paths. It's not just the academic path, but I thought I'd mention that today because that's the one that I took. You could do apprenticeships and training programs and all sorts of things, and T-levels and those kinds of things as well. So the UK is a good place to be if you're interested in having a career in the space industry. People have heard of NASA, maybe the European Space Agency, maybe the Chinese Space Agency. Often haven't heard of the UK Space Agency, but it does exist. Um, the government is putting money into jobs within our space sector, and there are more and more jobs being created across the UK. So it's not like you'd even have to necessarily move within the UK, let alone abroad, if you wanted to continue in the space industry. And there are hubs across the whole of the UK, you know, Scotland, Cornwall, the Northwest, the Midlands, and London as well, of course. There are lots of different types of jobs you could do. You could be an astronaut. We now have more British astronauts than we've ever had, but it's still a difficult role to get into. You could be a research scientist, a radio astronomer, an engineer, a teacher. You could do something like astrobiology. So if you're really interested in biology, but you also love the space industry, you could look at the biology of creatures that live in extreme environments on the Earth and think about whether they could survive the harsh extreme environments in space, and think about what aliens might look like and where they might be able to survive. So that's astrobiology. My background is planetary science, so I've studied the solar system and particularly Saturn. There's lots of different types of planetary science, including space weather, seismology, volcanology, looking at the bottom of the ocean, going to live in the Antarctica for 6 months at a time, and those, you know, sort of looking at all the different bits that make up Earth, but also looking at the solar system and planets within our solar system, but planets outside of our solar system as well, called exoplanets. There is a whole suite of more unusual jobs, and I'm just highlighting a few here. If you love space, but you're not that enamored with the sciences, there are jobs in the space industry for you. So you could be a space lawyer, a spacecraft salesperson, you could work in space insurance, you could be a space artist, a space chef, a spacesuit designer, science presenter, space journalist. Basically, if you like space, there's a job for you in the industry. And there are more and more, because we are venturing further and we're hoping to take human beings further, and there will be the need for more different types of jobs out there in the future as well. So I just wanted to show you some case studies from our careers booklet. There are a lot more online to have a look at. So the website was ras.ac.uk. So Anasuya is at UCL. She does Arctic research. She looks for aurora in the winter. She teaches. She's an admissions tutor, and that picture is her with a radar antenna in the Arctic. Dom Galliano is now a freelance science consultant, but has always been enamored with science outreach and education and presenting. So has done a lot of those kinds of things and worked in lots of different, worked for and in lots of different organisations with that. Joanne Wheeler is a satellite lawyer, which is an unusual job, I suppose, but again, working and living in the UK. She does things like government advocacy, policy, law, and regulation, all about satellites and space travel, and works on like large constellations of satellites and things like that as well. Sam Lindsay now works at the Ministry of Defence, doing data science, but has had a varied career, including a PhD in astronomy, and then was a research scientist before being a press officer and journal editor at the RAS, and is still at the Ministry of Justice now. Rosie Johnson has always been interested in aurora and the Northern Lights, but particularly for other planets. So is currently lecturing and studying Jupiter using data from the Juno mission, which is orbiting around Jupiter at the moment. And she's lecturing in outer planet auroras and those kinds of things in Aberystwyth University in Wales. Pial is a mechanical engineer building spacecraft or bits of spacecraft based in Leicester. And that's all the case studies I've shown you, but there are lots more on our website. And if you do want to learn more or get involved, a couple of good places include UK SEDS, which is the UK Students for the Exploration and Discovery of Space. And if you just Google UK SEDS, they'll come up. And then spacecareers.uk. They've had a overhaul in how they look, but the website address is the same. Spacecareers.uk is UK focused. There's lots of different things on there, including careers advice, job profiles, work experience opportunities, job opportunities. So do have a look at those websites as well. So if you wanted to learn more, then the RAS is a good place to go. Also have a look at the European Space Education Resource Office, STEM Learning. There's another Space Careers website called space-careers.com as well. And you'll, feel free to ask me questions. I just wanted to, that hasn't copied across very well. So there was a list of telling you what I do, but you don't need to read that. So I've kind of gone over what I do in terms of education outreach and diversity, and I'm going to show you some pictures anyway. But we do things like have school visits, visit us. We go out into schools. We teach GCSE astronomy. We give public lectures. We give keynote speeches. We represent astronomy at conferences nationally and internationally. We organise our own conferences and events. We publish journals and different educational resources if there's something going on. We do a bit of TV and media. So it's every single day is different, which is really nice. This is a picture from our GCSE astronomy class. You can see they're all eating pizza and watching Big Bang Theory. But we do all sorts of different things in class. It's a 2-year course, face-to-face and online. And at the end of the 2 years, then there's 2 exams in order to get your GCSE in astronomy. And I'm halfway through the course at the moment. So we're starting to think about exams and things in June of this year, or this academic year. We also do things like celebrating different landmarks and milestones. So this was celebrating the women of the Royal Astronomical Society. So the organisation started in 1820. Women weren't allowed to be members of the RAS until 1916. So 2016, we did a massive celebration of women members and women in history and the women currently as well. So we did a photographic exhibition, we did a Twitter campaign, we did lots of public talks and lectures and printed materials as well, but trying to highlight all the different women in our industry. I work with other organisations as well. So we work with Brownies and Guides. We do a space badge with them. We work with different charities. So the bottom middle picture is a intergenerational project. So working with young people and their grandparents to make artwork. But we affectionately call this lady the graffitiing granny in the middle there. And then on the right-hand side is teaching young people about earthquakes and geophysics, but using something that they might kind of relate to. So it's football. So what we did was put a seismometer at Leicester City football grounds during the year that they were winning the Premier League. And we could actually map every time one of them, most of the time Jamie Vardy, was scoring a goal, because the whole stadium would erupt in thunderous applause, and on our seismometer we would map tiny little earthquakes, and then we knew that Leicester was winning that match. So it's a relating space to things that we have on Earth as well, and things that we have on a day-to-day basis. During lockdown, we did a lot of online things. So if you want to sort of listen to more lectures and learn about space in a more visual and video format, our YouTube channels has got lots of things on there. Lockdown learning of different levels. So where did I come from? Well, where have I been in all of this? Well, I wasn't bothered by space, or I don't remember being bothered by space when I was very young. There I am dressed as a robot. I was lucky that I had a very sciencey upbringing. My parents were pharmacists. My sister's next to me, they're dressed as Mickey Mouse. She's a GP and doctor now. And I've obviously followed the slightly different path. I had to be a doctor as well, but not a medical doctor, obviously, a planetary scientist. The reason things changed was I saw the film Apollo 13, which was based on a real mission to the moon that failed. But I saw that film and I came out and I thought, I really want to be an astronaut. I really want to go into space. And that was when everything changed. I learned about astronauts. I learned about how they got to go into space and what training they had to do. And one of the things was to study, one of the paths was the academic route and studying astronomy and astrophysics at university level. So that's why I decided to do what I did at Manchester Uni, because of that. I haven't got into space yet, but I do say yet because I'm still planning on going one day, even if it's my retirement plan. But along the way, my career path has taken lots of twists and turns. So when I was 15, I did work experience at the Mullard Space Science Laboratory with this lady, Dr. Liz. Dr. Liz was an X-ray physicist, and she was amazing because she introduced me to the world of public speaking and outreach and engagement. And that became a passion of mine whilst I was doing my PhD and research science. So I got to go to Australia to do a research project about exoplanets, so planets outside of our solar system. But whilst I was there, I got lots of training and had lots of opportunities in public speaking as well. And then I've done all sorts of things on stage, making comets out of dry ice and telling jokes and funny things. So my PhD was around the Cassini spacecraft, which was a spacecraft built in the 90s, took 7 years to get to Saturn, and then orbited or went around Saturn for almost 14 years before being burnt up in Saturn's atmosphere. And being part of the Cassini team, learning more about Saturn, its rings and its moons was really amazing, because it was a very international team. It was a very diverse team, and it felt like a family. And you were learning things about a planet millions of kilometers away, and getting data about that nobody else had seen at the time. And now we know so much more about the Saturn system than we ever knew before because of this one spacecraft. So while I was at MSSL, I was learning about Saturn, learning about Cassini, also doing public engagement. So I organised open days where we had people come from the local area to learn about astronomy and space. And one of our open days that we organised is still one of the biggest ones that they've ever had. So, and it made the sort of local and national newspapers as well. So Cassini was really an incredible mission. The idea behind Cassini was conceived in the 1980s. It took quite a long time to get it through all the funding rounds and get it built. It launched in 1997 and got to Saturn in the early 2000s, 2004. It was really an international team, which was quite a big deal back then. Quite a lot of women were part of that team as well. It had 12 instruments on board. And it had the Huygens probe, which is this big orange dish. And you might be able to see the people at the bottom here for scale. So it really was a massive creation. One of the biggest things that I learned about Saturn and the Saturn system while I was studying it for my PhD were the moons and about the moons. And some of the moons are just mind-blowing. So the Huygens probe detached from Cassini and landed on the moon Titan. Saturn's moon Titan is bigger than the planet Mercury, and it has rivers, lakes, and rain and weather, but it's not liquid water. It's liquid methane, which is a gas on the Earth, but it's a liquid on Titan. And it's a really, really interesting place because we think it's like a young Earth, or maybe what Earth was like millions of years ago. And maybe if we keep studying Titan, we can learn about where the Earth came from and how we are now on the Earth. And maybe Titan is a place that we could look for aliens in the future. I also like moons like this, Mimas on the left there, because they remind me of things in science fiction, and I just think that's quite funny. And then my favourite Saturn moon is Enceladus. Enceladus is quite small. It's about the size of England. It's covered in an ice crust, and at the South Pole there are cracks in the ice. and Cassini was able to fly past the South Pole and realize that there's a plume or a geyser of water spewing out into space from that tiny little moon. And Cassini was able to measure what molecules and what chemicals were in that water. And we know that it's salty water. There's ammonia, nitrogen, sulfur, carbon, all these kinds of like building blocks for life type things in these in this plume of water going out into the Saturn system. And we think that Enceladus, underneath the ice crust, has a salty water ocean. And we know that we have salty water oceans on the Earth, and we know that different living creatures can live in these oceans. So maybe one day, you know, a job for you, send a craft to Enceladus, drill down through the ice, and actually have a look for aliens swimming about, you know, microbial little aliens swimming about in this ocean on Enceladus. Please let me know if you find something. Along the way, I have done a lot of other things as well. So when I was doing my PhD and realized I really liked public engagement, someone said to me, well, why don't you go into teaching and think about teaching? So I taught at a residential summer camp called Space School UK for 7 years, which was incredible. I also did teacher training and was a secondary school science teacher for a few years as well. Which was fun, but my main issue with that was that I had to teach physics, biology, and chemistry, and I really missed space. Space is such a tiny part of the wider UK curriculum, science curriculum. So that was partly why I didn't like teaching. That was pretty much the only reason. And that's why I teach GCSE astronomy now, because it's all about space. But then the job at the RAS came up, and I've done all the things that I've mentioned before. One of the interesting things at the RAS was being asked to do TV and media, which I hadn't done up until that point. So we got media trained and have been on things like Sky News and the BBC Breakfast Red Sofa and things like that. And then things like YouTube and Instagram as well. And it was through that kind of exposure that I then also met with a literary agent, and she came up to me and she said, oh, I really like all the things you do. Have you ever thought about writing books? And so then the last 5 years I've been writing children's nonfiction, mostly about science and space. So I've got 3 space books out now. I've got a few others that aren't space related. But How to Be an Astronaut and Other Space Jobs is all about careers in the space industry, very much like I've highlighted today. Space on Earth is about space spin-off technology, so things that were made for the space industry, but that we can use on Earth for better purposes. And then my most recent one is called Can You Get Rainbows in Space, which came out this year, talking about light and colour in nature and in space. So that was a really unexpected but really fun and enjoyable route that my career has taken, all because of being in the space industry. So at the beginning, I was like saying, you know, I've had a great career, but I feel a bit like a jack of all trades. I, you know, got this sort of like, who am I? Existential crisis. But hopefully you can see that it kind of doesn't matter that I don't have a specific label, but I've had like the best time because of studying STEM subjects, because of studying physics and astronomy, and because of being having a career in the space industry. And it's not just about being an astronaut, although being an astronaut would still be really cool. It's not just been about the career either. So when I've done the training, when I've done various bits of training and been to different countries and things, I have met people that I am like lifelong friends with. And I've been inspired by astronauts like Helen Sharman and Michael Foale. I also met my husband through studying space. So at university, during our PhDs, and now we have 2 children. So you can see that the solar system has changed my life, because without studying it, I might not have met him, and I might not have had my children as well. So I just kind of like to finish that I've been really inspired by role models and people who are in the space industry. And the picture on the left is Krista McAuliffe, who was a teacher and was supposed to be the first teacher in space, but unfortunately was part of the Challenger disaster and never actually made it. But I would absolutely love to take my sort of education and outreach background into space. And unfortunately, the picture in the middle is not really me in space, it's just fake. But I'd like to finish by saying space is really amazing. It really is for everyone. it can give you a really unusual career if you're proactive and you kind of try different things and don't be worried about asking questions. And with space, the sky isn't the limit, it's just the beginning. So thank you very much.
Thank you, Sheila. That was amazing. And I mean, where do we start? Obviously, you've had it was a very personal journey through what a career in space can look like, but obviously bringing in other case studies, which was fabulous. I'm sure people are sitting there thinking of any questions because you've had such a varied experience. I'll just start off with a couple, if that's okay. You talked a little bit about computational skills and computing. Now, obviously, you did allude to the fact that you can come into the sector from any sort of angle, really. But how important are computational skills, do you feel, to the future of the space sort of sector from an employment perspective?
It is necessary. I do think everyone sort of in the younger generation has infinitely better knowledge of technology and computational use than I probably ever had. In my undergraduate degree, they did teach us computer programming using C++. And then I did use a lot of programming for my PhD. But in hindsight, I would have, if I'd known that I could have, I would have chosen a different PhD that wasn't programming, because programming wasn't for me. So one of my friends has done a completely lab-based PhD where she is actually doing experiments every day with actual stuff and nothing to do with computers as well. And the only computer she's used is to write up reports or used Excel to make a graph or, that kind of thing. So it kind of is what you make of it. And you can not have to use it if you don't want to. And the other side is that you could come into the space industry with a computational background. So my husband has a background in maths, had no physics or astronomy experience at all, but because of his maths and programming abilities, he was able to become a solar physicist, so studying the sun, doing lots of programming, and now works for an architectural company doing the exact same programming as he did in astronomy, but for a completely different field. So it's never going to hold you back if you've got computational skills. But I think you are able to, if it's not for you, there are routes available for you as well.
Good, thank you, lovely. We have a question. Where did you go for your work experience?
Yeah, so I was really lucky. I grew up in London, and the school that I went to, my physics teacher was the one that kind of changed my perspective. And when she realised that I was into space and loved space, she set me up with Dr. Liz, who I've showed a picture of, who was based at the Mullard Space Science Laboratory in Surrey. And then I was 15 then, and then I went back when I was sort of in my early 20s, mid 20s, to do my PhD. Partly because I kept in touch with some of the people that I met. So that was very much via like a who you know kind of thing. I guess there are fewer opportunities like that around. One of the good places, well, some of the good places to look at for work experience are universities, because universities do work experience weeks. So I know Liverpool John Moores, I know Imperial King's, some of the other ones will do specific astronomy, space related work experience weeks where you can go and shadow an academic in the field. But if you're looking for work experience and you don't know where you could do it, don't be afraid to ask. I sent out loads of letters because the internet wasn't really a thing back then, but you could kind of blanket email hundreds of people if you wanted to. What's the worst that could happen? They'll say no, or they won't reply. But even if you sent out 50 emails, you might get one yes, and then you've got your work experience sorted. So
my son did something similar for geology, and he just found a geology directory of all the different companies that were on that directory, and then just sent out an email to them all. And he got a few responses. So one route to look was UK SEDS and space careers. You could perhaps just try and get a feel for what types of companies, names of companies, and then start to send your letters out or your emails out.
Yeah.
Perfect. Yeah. Thank you. Thank you, Rosie. So are there any areas of skills knowledge that make it easier to get into the space industry? So it's Rose, not Rosie, sorry, Rose.
If you want to do the more sciencey jobs in the space industry, then STEM subjects are important. If sort of triple sciences and then English and maths come up. When I did my PhD and then I did my teacher training, and when I did my teacher training, all they cared about was my GCSEs, and they cared about the fact that I had GCSEs in maths and English and triple sciences. So those were almost more important than the A levels and the degrees and the PhD. I guess it's different if you don't want the science route into the space industry, but I think that the triple sciences, maths and English are the ones that you really need to concentrate on. But then languages are good. Loads of physicists are quite musical and love musical instruments. Sort of part of it is making sure you do what you love and then picking up skills that way. Being able to talk is useful, and teamwork and that kind of thing. So the kind of transferable skills rather than the ones that are on paper as well.
I think it's having an inquisitive mindset, isn't it, as well? So it's as you say, it's those soft transferable skills that if you can demonstrate through something that you've been working on, it doesn't have to relate to the sector you're going into, but you can make that connection. Thank you. Rose has also asked about, you alluded to different ways of teaching maths. Now we do a lot of research around maths teaching, and there's an understanding of people look at maths in different ways, either a process or a pattern. And sometimes if you've got a disconnect, you have a process mind, your teacher's teaching it by patterns, you just don't meet, or the other way around. But also there's lots of discussions around applied maths, teaching maths in a way that's an applied skill. What was your take on maths having been in schools and looking at how maths is taught?
I just think if you can use something exciting as a hook and make it relevant, and that works really well. So I met someone recently who needed to learn about forces and levers and momentum and moments, all of that kind of thing. And they said, I'm rubbish at maths. I can't do it. I don't understand it. But then we realized that his hobby was climbing and high ropes courses and automatic belaying and all of that kind of thing. And actually, he was doing all of that maths in his head without even thinking I'm doing maths, but just because he loved it. And it was important to him. And also he was taking younger people out on trips, and he had to work out if this bit of rope would take that person's weight for safety purposes. And then it's just making it relevant. And I think at university, and further on, the maths was more relevant to the courses that I was doing. But I think maybe at school level, there's a bit of a disconnect between all the different subjects, and the physics teachers and the maths teachers just don't have time to talk to each other, even though everything is all related anyway. So
that topic-based curriculum where you can bring the maths and the other skills that you talked about into one topic and learn it in an applied way, if only. But that's something for policymakers to discuss. Caminus, hi. Have you ever helped develop a theory in astrophysics? And if so, what was that like?
So when you do a PhD, one of the provisos is that the stuff that you're learning has to be brand new. So nobody else could have done it before, because that's the sort of way you get your PhD. So the data I was using was data from Saturn that sort of was new as well. But when you're doing a PhD, you are putting together tiny little jigsaw piece puzzles in a massive jigsaw. So yes, I have. It was great. What I was doing was looking at the magnetic field of Saturn and looking at how big it was. And someone else had done that years before, but then I came along with new data and a slightly different model and released my new model, and it was called the Kanani model for a few years. And I had a paper that was published, and people would refer to it. But then someone else came along a few years later after that and did it, again, use new data and a slightly different model, and now nobody uses my model anymore. So it was nice, but it's short-lived. But you could take that two ways. Either it's kind of like a competitive thing, or it's everyone working together to make you know, to widen everyone's horizons. So
thank you, that's great. Thank you very much. But yes, great to have something named after you. That's incredible. Yeah, even for a short period of time, because everything's iterative, isn't it? It's all moving forward all the time. So I don't know how to refer to you, bad big sis. I'll say that. So you're homeschooled. I don't know whether you're studying any of our courses. So obviously all our course material is on our GCSE astronomy. But looking for books, and obviously you're now in the literary field as well, Sheila. So anywhere that you'd signpost someone around resources?
Yeah, if it's specifically for GCSE astronomy, there is only one textbook. I don't know if you can. Ooh, I've got a funny screen on, haven't I? So I don't know if you can. Oh, there we go.
Yeah, there it is. Yeah.
GCSE Astronomy 9-1. It's by Nigel Marshall. That's the only textbook that.
That's the one we have on our course. So that's good. We've got the right one.
It's EdXL have never put one out because it's an additional GCSE, but Nigel Marshall has always been the one. And then we use a lot of resources that are around, you know, sort of on the internet web. There's some really good websites and stuff as well. But if you're looking specifically for a GCSE astronomy book, you're at the right place.
Yeah, lovely. Thank you. That's good. And we also use resources published by Mickledore Publishing, which are a number of small resources for our material, which we have permission to do. So that's good. Yeah. And we also have, and obviously your organisation, Royal Astronomical Society, on the web, you have resources, so not specifically for GCSE, but just the topics around that, don't you? So good. So Lucas, you're planning studying robotics at university. Very good. What sort of career pathways would be available for me to get into space robotics? Ooh. Wow. Yeah. How competitive is the industry? It's quite a new industry, I think, isn't it, Sheila?
Yeah, that's what I was going to say. I think it's probably not that competitive at the moment because it's quite new. But I know that there is a lot of talk about robots in space, and there's a robot dog that they have sent or want to send to Mars called Kanani. I'm not sure. They have got various types of robots on the International Space Station to do kind of like the day-to-day work. And then obviously the things like the rovers that are sent to Mars aren't completely robotic, but are partly robotic. So there's definitely a place in the space industry for someone who's studied robotics at university, but I'm not sure much else about that, unfortunately. Sorry.
I suppose the university course leader would have further information. I think, as you said, that the university that you're studying at, they sort of have quite a lot of days and sort of work experiences and things. So Lucas, I think advice is once you're at university, that the lecturers there will have industry connections, which will be really exciting to explore with them. I'm sure your passion and inquisitiveness around it will mean you'll get onto a good placement. So it's sometimes quite good to have a sandwich course as well, isn't it? Because then you get an industry placement aspect. Jessica, you've now said what your name is. That's lovely, thank you. Ah, yes. So Sheila, you did note this at the beginning, astrology and astronomy. Yes. So just for those who perhaps are unsure of the difference.
Yeah, so well, modern astrology is what we think of like star signs, and you know, I'm Sagittarius, so I'm going to be grumpy on Friday and that kind of thing.
But is that true?
Well, I am Sagittarius. I'm normally quite happy on a Friday, seeing as it's a Friday. But astrology really, so I think a lot of people kind of look down their nose at astrology now, but it really was where astronomy started. So it was using seasons and star positions and phenomena like solar eclipses back in ancient times, like with the ancient Indian, like as in Asian Indians, not like American Indians, ancient Indian people, Arabic people, where you didn't have the technology and you were doing astronomy, but it was kind of more related to gods and mythical ideals and stuff. Because of not having that technology, it's kind of like, you know, if you see a solar eclipse and you don't know why that's happening and it's 3,000 years ago, you're going to think it's like a god raining down on you, aren't you, sort of thing. So astrology is kind of where astronomy started. but with technology and with more knowledge and maths and things. Astronomy is where we've ended up, and now there's that kind of divide of, you know, I can't tell your fortune using a crystal ball, but I could tell you when the next solar eclipse is, kind of thing.
Yeah, so to understand the root of modern astronomy is,
Yeah.
and that's often quite a lot across other disciplines we have. They started off in a way that people were being curious about the world and tried to make sense of it in their own way at the time, which was where star signs, I suppose, came about. But then obviously as science develops, there's a different way of looking at that.
Yeah.
Fascinating. Thank you. We've got a couple of goodbyes and thank yous. So people are finishing up now. Really interesting, Sheila. And, you know, really, you've got so many different avenues that you can, you know, explore yourself. You've got lots that you're exploring. And that was really good to give everybody who is listening and is going to watch in the future a real understanding of the different ways that you can explore space, but in your career. So thank you for your time. Thank you, everybody, for your questions. And thank you for joining us.